All right, well, this is our first lesson in geometry, lesson 1-1, points, lines, and planes. And you can see the goal there is I can define and name points, lines, and planes and use related terms. Well, a lot of geometry is not mathematics. A lot of geometry is just vocabulary and concepts related to that vocabulary. So it's really important that we build a correct base of vocabulary so that we can communicate and understand one another. So that's why this section's here. So let's just jump right into it. Hopefully you've got your notes each week. You can just print out the notes for the lesson that we're going over that day. Today happens to be 1-1. So we're just going to go through some terms here. So a point and definition for a point is just a location in space having neither shape nor size. You can name it using any capital letter. There's going to be a real difference between capital letters and lowercase letters as we go through geometry this year. So you'll want to make sure you know when it says capital letter that lowercase is not okay there. It really needs to be capital. So there's a point there. Obviously, we have to give some kind of marking. So we do have a marking there of a little dot. And then we put the letter A next to it to indicate that that's what that point is called. A line, well, the definition of a line is it's made up of infinitely many points. It has no width and has no length. And the reason it doesn't have any length is because a line continues forever in both directions. So you notice the arrowheads on the ends of this particular line. That indicates that it goes on forever in both directions. So it's got an infinite number of points because for any 2 points like P and Q here on the line, there's always another point that can be placed in between them. Like maybe we can put R in there. Well, then between R and Q, we can put S, and between S and Q, we can put T, and we can just get this line infinitely small and still find yet another point between any 2 points that are on that line. That's why there are an infinite number of points, okay? So 2 points, how you name it. You can use 2 points that are on the line. Let me get rid of some of our points that we added here. So 2 points on this particular line that I placed were P and Q. So you can use those two with a symbol, or you can use a lowercase script letter. Notice this M out here on the end. This M is a lowercase script letter. And in order to use that for a line, it's got to be written out there by the arrowhead. So notice this is by the arrowhead there. And that indicates that it's the lowercase script letter for that. So here's how you would write that. So this could be line M, like you use the word line, and then the lowercase script letter. You could use the 2 points with the word line PQ, or you can use the symbol for a line, which is just a little line, and you just place it over the top of the 2 letters P and Q, just that little sketch of a line there. And that's a line. Array. Well, array is just part of a line. It's got an endpoint, and then it goes forever in one direction. So it's literally not half of a line because lines don't have any length, so you can't really cut it in half. But it just starts at a point and goes forever in one direction. So if you'll notice, this particular ray starts at J, and then it goes to the right towards B and L. You can see the arrowhead here on the end telling us the direction it goes. So you can name a ray using the endpoint first. Very important that you use the endpoint first, and then any other point on the ray. So notice both of these have J first because J is the endpoint of this ray right there. So I could call it ray JL or ray JB, and notice the symbol over the top again indicates it's a ray because it's just a smaller picture of a ray, just like we had a small picture of the line. So that's a ray. It's like half of a line. A line segment. Well, a segment is a piece of a line, and this time it's bounded by endpoints. Bounded means it has boundaries. It doesn't go forever in both directions. It has a definite length. So there's a definite length from P to Q. And the way we name a segment like this is using the endpoints. So PQ are the endpoints, and then we put this segment, small picture of a segment, a little tiny segment above those two letters to indicate that that's what shape it is. It's a segment. Collinear and non-collinear. Well, hopefully you can see the word line written in these words. Collinear means on the same line, and then non-collinear would obviously be points that are not on the same line. Now, you can't say that 2 points can't be collinear. Like down here, I've got point P and then point T is not on the line. You can't state that P and T are not collinear just because there's no line there, because I could draw a line through any 2 points. So if I wanted to, I could just come up with a different line like this, and I can say, hey, see here, PT, they're collinear because I can put them on the same line. When you say collinear or non-collinear, it usually involves or will involve 3 points. So you're always discussing 3 points. So in this case, what 3 points are collinear? Well, P, R, and Q are collinear. P, R, and Q, they're on the same line. But I couldn't say P, T, and Q because there's no way to make a straight line through P and T and Q. So we would say that P, T, Q, they are non-collinear. Okay? They cannot be on the same line. The line would be crooked. And lines have a straightness property. Lines are always straight. They don't curve. They don't bend. Okay? So that's collinear, non-collinear. Collinear on the same line, non-collinear not on the same line. A plane. Well, a plane is just a flat surface. It's made up of points, and it extends forever or indefinitely in all directions. If you notice in the picture, though, I've drawn something like a rectangle there. You have to show the edges of the plane in some way, otherwise you don't know it's there. So I'm just drawing those lines to let you see the plane, but it really does extend forever, just like a line extends forever, okay? There's exactly one plane through any 3 non-collinear points. Have you ever noticed why or wondered why photographers use a tripod? It's because a tripod, those 3 points, always sit level. It doesn't wobble back and forth. You ever sat in a 4-legged chair and it kind of rocks a little bit because one of the legs is shorter than the others, or maybe a table at a restaurant tips and kind of moves back and forth because one of the legs is shorter than the others. You have to prop it up. Well, that's what this means right here. There's exactly one plane through any 3 non-collinear points. If you took a tripod and put all 3 legs in a straight line, it would fall over. But if you put them in a way such that one of them is not on the same line as the other 2, like P, R, and T down here, they are non-collinear. So that's how we name a plane, and that's why we just talked about what non-collinear means. To name a plane, you have to use 3 non-collinear points. So I could call this plane, I could call it plane PRT. I could call it PTQ, but I cannot call it P, R, and Q because they are collinear. Okay, they're on the same line. The other way you can name it is this script letter. It needs to be more of a fancy K, like you do in cursive, something like that maybe. You can use using one letter, and that letter usually is in the corner. Notice it's not labeling anything else. M's labeling the line, P's labeling that point, R that point, Q that point. But then you got this letter K over here. It doesn't seem to be naming anything. Well, tucked away in the corner like that, it's naming the plane. So we can also call this plane K. Coplanar, non-coplanar is just like collinear and non-collinear, except with a plane. Okay. So coplanar points are points that lie on the same plane. So P, R, and T down here, coplanar. And you know, with these, I'm not going to trick you by saying, well, T is slightly above the plane. You just can't tell in the drawing. We wouldn't do that to trick you in some way. If the point or line is inside the box, it's in the plane. That's what you should know. Is if I wanted to show a point that wasn't in the plane, I'd do something like this. I'd place it outside the box so you can clearly tell that that point is not inside that plane. Okay? So coplanar, PRT. Any 3 points are always coplanar. Okay? But 4 points aren't necessarily, like PR, Q, and X. So you've got to talk about 4 points being non-coplanar. So any 3 I name are always coplanar. 3 are coplanar. 4 points, maybe, maybe not. PR, Q, and T are all 4 coplanar. But if I use PR and PRT and then X, those 4 points, well, 3 are in the box, so 3 of them are on the plane, but the 4th one is not. So we would say P, R, T, and X are non-coplanar. Okay? Segment bisector. Well, any segment, line, or plane. Notice there are 3 things that can do the bisecting here. A segment can bisect a segment, a line can bisect a segment, or a plane can bisect a segment. And they do that by intersecting it at its midpoint. So let's look at, we're focusing on segment BG. So BG, well, it has been cut in half by line M because it passes through the middle or the midpoint. So M is our midpoint in this example. So line M goes through capital M. FC, segment FC goes through capital M. So line M, FC is a bisector. And then plane N is a bisector because all of those pass through point M, which is the midpoint of BG. So they cut BG in half. So that means like if BM was 5, right, then we could say that MG is 5, just for example. So let's do some practice here. So name the plane with 1 letter. So if I had to name the plane with 1 letter, I would say plane, and then I'm going to use my script letter here in the corner, plane, and I'll make it more script up here in my answer. So number 2, name a line in the plane. So there's several things we could do here. Notice there are 2 lines that kind of pass through the plane. That's this line here and this line here. So we just got to figure out what the best way to name those is. So we could name line M. That's this here. I could also call that line EB, or I could call it BA, or I could call it EA. So it is not different if I call it AE. These are the same right here. These are the same line name because I used the same 2 points. So that's not another name. It's just another way to write line EA. So here's some other lines in the drawing, right? We've got line FB. We've got line BC. We've got line FE. Oh, excuse me, C. Okay. So name a line not in the plane. line not in the plane would be, there's only one, and there's only one way to name it. That's BG. See how it goes through the plane? This dotted line section right here means it's hidden behind the plane. So it kind of disappears as it goes through the plane, then it comes out the bottom. And you can see it again down here. All right. Let's name a ray starting at point E. So a ray starting at point E would be ray E. And then I can only move in one direction and name another point. It's either EB or EA. I can't go E towards the M because M here doesn't name a point. It names the line itself. So we either have to go ray EB or we could go ray EA. Those are two names for the same ray. Okay. Let's name a segment along line M. So a segment anywhere on line M would be like EB with a bar, EA with a bar. Oops, I already had a bar. And then AB with a bar. Those are all ways to name a segment along line M. Okay. So there's an assignment there in IXL. Geometry B1, lines, line segments, and rays, and I need you to try and get a 90% on that.